Hello and welcome to webinar of Achieving High Availability and Durability with Multi-AZ on Amazon RDS. First of all, my name is Vijay Karmaji. I'm a Senior Specialist Database Solutions Architect here at AWS, and I specialize in MySQL database engines, including Aurora and RDS MySQL and MariaDB. So let's get started. So the agenda for today is we will start with an introduction to AWS infrastructure and some background information that will be quite helpful in understanding how AWS has implemented RDS for MySQL and MariaDB. Then we will drill into high availability and best practices around it. We will spend some time discussing disaster recovery, and then at the end, we will answer some questions you have in webinar chart format. The region and availability zone architecture are fundamental to how we think about availability at AWS. As of today, AWS infrastructure spans across 25 regions and 81 availability zones globally, with more already underway. AWS Global Infrastructure, we group things logically into availability zones and regions. And I like to think of a region as a geographical location where we can build highly available applications. To achieve this, each region is built from a cluster of data centers organized into availability zones, AZs. An availability zone is one or more physical data centers that act as a single logical data center for you. And in that data center, you would have compute resources and database resources. On the slide, as you can see, we have region 1 and region 2, and each region have 3 availability zones, A, B, and C. Each AZ in a region are physically separated from each other by a meaningful distance and connected by high bandwidth, low latency fiber with independent power, cooling, and physical security. This means that AZs are close enough that you can synchronously replicate between them, but far enough apart that failures affecting one are not likely to affect another. Which region you use is an important decision. Typically, you want to choose the region that is closest to your customers to ensure lowest latency, or choose the region based on geographical location where the data locality and sovereignties are important. Which availability zone you use is not important. AZs within a region should generally be treated as interchangeable, and your application server should spread across as many as possible to ensure the highest overall availability. Hopefully, you are familiar with Amazon Relational Database Service, RDS. However, RDS is a managed database service built on top of other fundamental AWS services like Amazon Elastic Cloud Compute, EC2, Amazon Elastic Block Storage, EBS, and Amazon Simple Storage Service, S3. Amazon RDS provides choice of 6 popular DB engines. What we mean by that is we take database engines. Some of them are commercial database engines like Oracle and SQL Server. Some of them are open source engines like MySQL, MariaDB, and Postgres. And we put a management layer around them to provide automation for very common tasks that a lot of DBAs or DevOps engineers that operate these databases have to otherwise do manually. And what it brings to the table is ease of administration. You don't have to worry about things like patching, installing software, provisioning those databases, and maintaining them over time. We take care of that for you in RDS using our automation process. And we also provide you easy capabilities to scale those databases. With RDS, all these tasks just a simple matter of checking a box or setting a flag in a configuration. RDS has built-in features for availability and durability, which we will talk about today, while we'll provide you with highly performant databases, we also design such that these environments that are highly secure to meet all the potential security needs of an actual production application. So we're going to cover some of the background terminologies here. A couple of key points when we talk about high availability and disaster recovery are RPO, recovery point objective, and RTO, recovery time objective. The green line here represents the ongoing activities of my database. And you can see that some sort of incident has disrupted it. If I have to restore from backup, then the recovery point is in the past, and my data loss is determined by how far back I had to go. A recovery point objective, represented here in blue, it describes the maximum amount of data loss expected with a particular recovery action. And the recovery time objective, represented in orange, is the amount of time the recovery action takes to get back to production. And that means back to the green line. So the RPO and the RTO are two important factors needs to be considered when we design the high available and DR solutions for the applications. When planning and designing your database architecture, you start by identifying the RPO and RTO that your application requires, and then use the features and recovery actions that satisfy those requirements. We have synchronous and asynchronous replication options available, and we are going to discuss those as we go along through the slides. Synchronous means that the writes are hardened on the standby server first before the commit of a transaction occurs on the primary server. So I know that if anything goes wrong on my primary server, my standby is 100% in sync, and I don't have the possibility of data loss. In asynchronous replication, if my application commits a transaction on the primary server, the acknowledgement of the transaction happens immediately to the client application. However, in the background, it is going to send those transactions to standby server and gets updated. But application does not need to wait for an acknowledgement from the secondary before continuing on with additional work. Additionally, in RDS, we have automatic failovers from primary to secondary servers, as well as you have capability to do manual failovers as well. And finally, physical versus logical replication. We do have options for some of our database offerings to have complete physical replication of the data. In other words, block for block replication at the disk level. And we have logical replication options, which is what we offer with RDS for MySQL and MariaDB, which means the database engine is going to logically send updates in binary log format, and then we would replay those binary logs on the replica servers. Now that we have a firm foundation on AWS, RDS, and recovery terminology, we are ready to talk about how Amazon RDS takes care of replicating your data within and across AWS regions, and how that affects the RPO and RTO of a few different scenarios. Let's look at how can we achieve high availability with Amazon RDS. Before we dive into RDS high availability, what do we need to consider for high available applications? There are two important areas to consider when looking at high availability for your applications. First, what are your high availability requirements? And second, what else impacts the availability of your application? I find that customers are most successful when they're able to clearly define the RPO and RTO requirements for each workload. It's important to think of things like, what is your current level of availability? How are you measuring that? And are you meeting your current goals? And then what is the required level of availability? What is the business driver for that requirement? And is it reasonable? And finally, once you settle on a design, go back and review whether it meets your requirements. If it doesn't, why is that? And is that reasonable? Not all applications require high availability, and there are practical limits to the availability of any one database. But starting from business requirements will help you make the right decision for your particular use case. As you know, the database is just one part of your application. So it is also important to understand the other things that impact availability. For example, are your application servers spread across all the availability zones in a region? Or do you have hard dependencies on some service or resource that is only configured in a single AZ or single region? Or for the portion of your application that talks to the database, how does that handle disconnects when the database fails over? While you should be able to answer these questions, it is also important to actively test your applications to understand how they are impacted by different failures. So how do we achieve high availability? With Amazon RDS for MySQL and MariaDB, it is absolutely as simple as selecting Multi-AZ checkbox option when you're creating or modifying your servers. When you select Multi-AZ, that is going to add synchronous replication to second availability zone inside your Amazon network within a region. And you're going to have two completely independent infrastructures in different physical data centers for failover. As we discussed, they are physically separated with independent power, cooling, and physical security, etc. As they are in different availability zones, if we lose an entire data center, Amazon RDS can handle that failovers automatically for you. This allows us to offer a 99.95% uptime SLA. Let's look at a single availability zone. In a single availability zone configuration, the compute node and storage volumes for an instance are created in a single availability zone. As you see on the screen, we have a region, and then within that region, we have three availability zones, A, B, and C. And our applications are spread across all three availability zones, but our RDS instance is within a single availability zone A. If the compute node fails or database crashes, RDS automation takes care of getting things back up and running, usually within minutes, but sometimes longer. If an availability zone itself experiences failures when your instance is running, something that is rare but can happen, your application may be unavailable until the problem is solved and your instance can be brought back up. So how do we fix this problem and improve the recovery time objective? By simply enabling the multi-AZ option. For workloads that require high degree of availability, RDS multi-AZ creates a secondary instance with exact same EC2 instance type and EBS volume configuration in another availability zone. It then sets up synchronous replication, maintaining an exact duplicate of your data on the standby replica. So let's see how multi-AZ replication works behind the scenes. In multi-AZ configuration, When MySQL and MariaDB writes to disk, the storage layer transparently replicates the changes to the standby instance. Once the writes are hardened on the standby, it sends an acknowledgement back to the primary, and then client gets the notification from the primary. Because AZs are relatively close together, we can do this write synchronously to reduce the risk of data loss. It can increase latency by small amount compared to single AZ. So the write latency is now cumulative of both local and remote writes. It is something you should test carefully with your application, but most customers find this to be a reasonable trade-off. Now let's look at some of the multi-AZ failure scenarios. If the secondary instance fails or becomes unavailable, Amazon RDS monitoring system automatically detects and fixes the problem and restores high availability, all with no impact on the primary instance or application sessions. Now let's look at what happens when primary becomes unavailable. If the primary becomes unavailable, RDS automatically converts the standby into a primary, allowing your applications to reconnect. And then RDS takes care of reinstating the failed primary as a standby instance and restores the high availability. Notice here that my application servers are running in all three availability zones. In this case, even though my database is only running in two availability zones. Remember, the database is just one part of the application, and there are other edge cases to plan for. By using as many AZ as possible, your application is best able to absorb the impact of losing an entire AZ. Also, in RDS multi-AZ configuration, the primary and standby RDS instances have the exact same configuration in each availability zone. This means that there is no need to fail back after the fault has been resolved. So there is no need for second outage. With multi-AZ, your RDS instances will run in AZ-A for a while and AZ-B for a while, and so on. Again, which AZ you use is not important. Now let's look at what happens during the failover. After the primary becomes unavailable, it takes our automation a few seconds to detect and confirm the failure to ensure we don't fail over unnecessarily. The failover itself consists of two key operations in parallel: database crash recovery and DNS propagation. In the crash recovery phase, the database starts up and returns data files to a consistent state. The process is no different than if the database had simply crashed. In fact, the database doesn't even know it is running in a different place. The very last transactions committed in the moment immediately before the failover were synchronously replicated, so no data lost in a failover scenario. Any uncommitted transactions that were in flight when the failover occurred are rolled back by crash recovery. Again, it is no different than if the database had just crashed. The failover also involves a DNS change to update instance endpoint to a new IP address. This way, applications don't need to be reconfigured or modified at all after a failover. In most cases, that process takes 1 to 2 minutes. Now let's look at some of the benefits of multi-AZ. First of all, multi-AZ provides high availability with 99.95% monthly uptime SLA. And system upgrades like OS patching or DB instance scaling. If we initiate these kind of activities, They are first applied on the standby, and then we do a failover, and then we will apply them on the your old primary. Because of this, it will improve the availability of the application. And also we take backups on the standby instance so that we don't need to have any impact while taking the backups. And after a failover, the endpoint remains the same, so no need of any application changes at all. Now let's talk about some of the best practices for multi-AZ. As you know, stale DNS entries can cause connectivity issues after a failover. The failover mechanism automatically changes the DNS record of the DB instance to point to the standby DB instance. As a result, you need to reestablish any existing connections to your DB instance. In a Java environment, the JVM environment, due to how the Java DNS caching mechanism works, you might need to reconfigure the JVM settings. Because in the JVM settings are such that you may need to reboot your JVM servers to re-establish the connections. That's why always advise to set DNS TTL to less than 5 seconds. And also, to shorten the failover timings, RDS provides RDS proxy. RDS proxy minimizes application disruptions from outage affecting the availability of your database by automatically connecting to a new database instance while preserving application connections. When failover occurs, RDS proxy routes requests directly to new DB instance. This reduces failover time for RDS databases by up to 66%. And also ensure that you have a sufficient provisioned IOPS on your EBS volumes so that during the failover, we can use these IOPS to recover much faster. And also make sure you have small transactions because we can improve the database recovery process. Databases are one part of the application. So deploy applications in all availability zones for better availability. And also you can leverage RDS DB events to monitor failovers and then get notified by emails or SMS. And finally, test the failovers regularly. Now let's look at some of the disaster recovery options in RDS. There are some things for you to think about when planning for disaster recovery. We will talk about how RDS enables disaster recovery, but you will still need to decide which features to use and when to use them based on your RPO and RTO requirements. For example, what constitutes a disaster recovery for your application? So it is important to understand which situations require recovery in the first place and which scenarios make sense to just wait it out. What about the other infrastructure required to run your applications? If you can readily make your database available in another region, will you have application servers, load balancers, and other resources up and ready to go? Most disaster recovery scenarios involve at least some amount of data loss. How will you ensure your applications are consistent, and how do you decide what is acceptable? If the original system becomes unavailable again, how will you reinitiate the data that didn't make it to your DR site before the recovery action? As with high availability, it is important to have a clear understanding of your actual business requirements. What are the RPO and RTO requirements for your application? What drives those, and are they reasonable? Finally, disaster recovery scenarios have many moving parts. So it is important to have a test plan and periodically exercise it with disaster recovery drills. So let's look at disaster recovery options with Amazon RDS. We're going to talk about three major features that RDS enables disaster recovery. First, RDS backs up your databases to Amazon S3 by taking storage snapshots and copying binary logs. This allows you to create a new instance at any time, either from snapshot or to a specific point in time. Second, RDS, MySQL, and MariaDB supports push-button read replicas. You can create a read replica with a single click. And you can create them within a region or across the regions. Read replicas are fully managed and can be promoted in place to become a primary instance. Finally, you can configure external replication between RDS instance and on-premise infrastructure. For this approach, you can use native binary log replication or third-party replication softwares to extract changes from the source database and apply them to your target database, which will be on your on-premise. Okay, let's start with backups. There are two ways to backup your RDS instances. The easiest is to enable automated backups. Each day during 30 minutes backup window you specify, RDS takes storage snapshots for your databases. By default, if you create an RDS instance using AWS console, the default retention of your RDS automated snapshot is configured to 7 days. And if you create an RDS instance with AWS API or CLI, the default retention period of your database is 1 day. So make sure you change those backup retention periods as per your needs. When you enable automated snapshots, we also take binary logs backups continuously to S3 every 5 minutes. And another point with automated backups is whenever you delete an RDS instance, you can still retain your automated backups with single checkbox, which you enable while when you're deleting the RDS instance. And RDS also provides you manual backups. You can also take manual backups of your RDS instance at any time, even if automated backups are not enabled. So if you want to take a manual backups, you have a backup policy that you want to keep backups more than 35 days, then you can have manual backups configured for your RDS instance. And these manual backups will automatically retain until you manually delete them. And also you can convert your automated backups to manual backups by simply doing a copy API call on your AWS console. Amazon RDS snapshots built on Amazon EBS snapshots. Automated backups occur daily during the preferred maintenance window. And these backups, what we take, are always incremental. For example, if you have 1 terabyte of database, the first copy of the data will be 1 terabyte. And then any other snapshots you take afterwards are incremental. That means if you modified only 1 gig of data, then the second snapshot will have only those increments, only the change blocks which are modified after the first snapshot. And from the performance point of view, if you're using a single availability zone, requires a brief less than 10 milliseconds pause on the I/O to take the snapshots. In a multi-AZ, as we discussed, snapshots are taken from the secondary, so you don't see that kind of a brief latency when you use multi-AZ. But after you initiate the snapshots, there won't be any performance impact while we are taking snapshots of your data blocks. And also, these RDS snapshots, you can copy across other regions and other accounts. If you have another DR account, you can simply copy the snapshots from your production account to your DR account. You have that capability as well. And also, you can copy it to across the regions as well. So now we have the backups. Let's look at restore from a snapshot, how it looks like. When you initiate a restore, it creates a new instance from that snapshot. You can restore a snapshot within a region or across the region or in a different account as well. So what are some of the use cases to restore a snapshot? You want to maintain a master image copy of your RDS instance. So for that, you can take a master image and then use that as a template for your applications. And you can use this restore from snapshot as a disaster option as well. And if you have some of the application changes, or if you want to test upgrades, then you can simply initiate a restore snapshot. As it creates totally a brand new RDS instance, you can test upgrades on top of it. And then you can test your new application changes. And some use cases I have seen for clone environments. If you have any requirement like that, if you want to clone an environment, you can use RDS snapshots as well. RDS also provides a restore to point in time. A restore point in time also creates a new instance completely. However, instead of specifying a snapshot to restore, you specify a specific moment in time down to the second. RDS takes care of identifying the closest snapshot and creating instance and rolling the database forward by using binary logs until the recovery time is reached. Because this requires binary logs, it is only available when automated backups are enabled. And the restore time has to be in your automated backup retention window. With point-in-time restores, RPO can be as low as 5 minutes when using the last restorable time for your instances. RTO will depend on the amount of workload that has to be replayed. Point-in-time restore is only available in the same region and account as the source instance. So this solution can't help with across-region failures today. And then next option, what we have is Amazon RDS for MySQL and MariaDB read replicas. These are fully managed MySQL MariaDB native replication. So you don't need to manually configure any replication between the primary and secondary, right? It uses the negative binary log replication, and which is an asynchronous. That means you have some replication lag between your primary and a replica. So we also provide you capabilities to look into the replication lag in your CloudWatch metrics. So you can monitor replication lag in the CloudWatch metrics. So the replication lag normally depends on amount of work you're doing on the primary, so that you have that much of replication lag, because we need to take the binary logs and then apply them on the replica. So it takes some time. So if you're using a read replica as a DR, then you may need to think about the replication lag. You may need to monitor your replication lag. So you have to keep that in mind when you use a read replica as a DR solution. And in RDS, you can have up to 5 read replicas of so you can create 5 read replicas within a region or across the regions as well. And once you create a read replica, if you want to keep that read replica in a multi-AZ configuration, you can do that as well. Read replicas can be promoted as a new individual standalone instances as well. Let's look at some scenario here. So I have an RDS instance, and which is configured with multi-AZ configuration. My RDS instance in primary is in A, and then standby is in B, and it has a synchronous storage level replication. Now I want to create a read replica. So now I created a read replica of my instance 1. My instance 1 read replica is in availability zone B, and which is an asynchronous binary log replication from my instance 1 multi-AZ primary to read replica 2. And if you want, you can create additional read replica from a replica. So as you see here in availability zone B, my read replica 2, I have created another read replica in availability zone C. So you have the capability to create a chain replication, if you will. And also, you have a capability to create a read replica within the same availability zone as your primary, if you want to. So you can use that for read scaling. And another important point here is, as we talked before, right? In a multi-AZ configuration, you will be having the same compute resource sizes. But with read replica, you can have different instance compute sizes as you require. So as you see here on the availability zone A, I have a 16x large R5 16x large instance class. And then in read replica 2 with a different instance classes, and read replica 3 have a different instance class. So it depends on your workload and depends on your use case. You can create a different size of instance classes for your read replicas. And then cross-region read replicas. RDS provides a fully managed cross-region read replica for you. So as you can see here on the region 1, I have a primary and then 2 in-region read replicas. And then these 2 read replicas, I can use it for read workloads. And then I have also created another read replica in region 2. And here also you can span your read activity across the regions as well. You can use that read replica for read scaling, as well as you can use it for DR purpose as well. In case of a disaster, if you want to have a secondary region as a DR, right, you can simply promote your secondary region's read replica as its individual replica. Now it becomes its own primary read replica. So you have that capability with RDS as well. So another option what we have is external replication. So as you see here, we have a RDS instance in region 1, and then we configured the external replication, which is on-prem MySQL instance. You are setting up external replication to on-prem as your DR, and you normally configure, RDS provides you to configure replication between both of them. So you have to execute some of the RDS provided store procedures on your on-prem, and then that sets up the asynchronous replication for you. So here, the replication lag depends on the distance between both of them and the network between both of them. So if you think about it, the RPO is totally depends on few factors, the network between both of them, and then amount of activity you're doing on the primary. So RPO might be huge compared to the replication, what you see within the AWS region between the RDS instances. So it depends on that. You may want to choose what is your best DR solution for your applications. It depends on your RPO and RTO requirements. But you still have these capabilities to do that too. And then to conclude, so far what we have learned, we talked about multi-AZ for high availability, where we talked about RPO is 0 and RTO is 1 to 2 minutes because of the failover process, DNS propagation, and everything. And you can decrease that even using RDS proxy or any other proxies what you normally use. You can decrease it to decrease that RTO to less than 2 minutes too. And we also talked about automated snapshot and restore. Normally, RPO would be, in this case, depends on how far back you go for your snapshot. Depends on that, your RPO defined, and your RTO is less than an hour. So if you're using, I have seen customers restoring a snapshot in few minutes. But end of the day, it depends on how much amount of data you have, as well as what kind of compute resources you are using, and you have enough IOPS to do that work for you. So less than 1 hour. And manual snapshot restores depends on time of the snapshot when you took that manual snapshot restore. And then RTO is same as your automated snapshots, because amount of time it takes to restore and go through that recovery process. And we also have point in time. We talked about point in time restore. RPO is as we discussed, when you do point in time restores, and when you enable automated snapshots, we continuously take binary log backups every 5 minutes, right? So point in time restores uses those binary logs to replay it on top of your snapshots. So that's why we see RPO is 5 minutes, and then RTO is less than a minute to several hours, because it depends on when was the last time you had a full backup. So that's why the best recommendation, if you want to use point-in-time restores, is frequently take manual snapshots, so that when you initiate a point-in-time restore, we can take the latest backup and then apply the binary logs on top of it. And we also talked about read replicas in region and read replicas across the region. And RPOs here depends on the replication lag, and RTO is less than 5 minutes. And we have external replication options as well, and that depends on the replication lag and the network between both of them, and amount of activity we do on the masters depends on that. So, but RTO is minutes to an hour. It depends on what's really happening at that point. So that's all I have for today. Thanks for spending this time with me, and have a great day. And thank you for attending today's webinar. I really appreciate it.